Yes, hello, Mr. Varun. Welcome on Utopia platform, and let's start your thermodynamics now for your final JKPSC interview for the post of Assistant Engineer in Public Works Department.
So,
So,
thank you.
Varun, what you studied in this subject, thermodynamics?
Sir, actually, I have done M.Tech in machine design, so I've just studied the basics only.
So, you did masters in machine design.
Yes, sir.
Why you are preparing these subjects like thermo?
Sir, actually, I'm covering all the subjects, but
Hmm.
I'm just focusing mainly on the machine design subjects, but I'm just studying the basics of other subjects also.
Varun, what do you understand by conservation of energy?
So, conservation of energy means the total energy of the system will be conserved. It will be converted from one form to another, but it will not be degraded.
So, energy is not going to degrade in a process.
Yes, sir.
Can you give me any example like where the upgradation of energy is taking place?
Like a heater, in the heater, electrical energy is getting converted into heat energy.
So that is
And
upgradation. I feel that is a degradation.
okay, because I mean, some
You know,
entropy is
there
also
is a
associated.
very important statement of second law of thermodynamics.
Yes,
And
sir.
according to that statement,
Efficiency
the
cannot be 100%.
all real processes takes place in the direction of degradation of energy.
Yes, sir.
Because in
Because
all real processes, we are going to lose the work. Some work we
okay,
are going to lose, definitely, always in all real
okay,
processes. And due to work loss in all real processes, we are moving in the direction of what? Degradation of energy.
yes, sir.
For
So
example, you
the
are
correct,
converting
so the
electric
correct word
energy
would
into. Mhm.
yes, sir. So the correct word will be destruction of energy, not degradation of energy.
Degradation, destruction, both are same. Varun. Destruction means what? Degradation. Destruction means what? We are losing work. So all real processes are also going to take place in the direction of destruction of energy.
Okay.
Work we are going to lose in all real processes. Varun. Work is not conserved. What do you feel? Like energy, total
Mm-hmm.
energy, work is also conserved in a process.
Uh, Sir, actually, it is getting converted into another form of energies.
For
Like
example, you are converting work. Maybe suppose you are converting the kinetic energy of a
mm,
gas. Okay, for example, let's take an example of a windmill. So what do?
okay,
We convert the kinetic energy of the air into the shaft energy, shaft work,
yes, sir. Yes,
mechanical
sir.
energy, and further
Yes,
we utilize that mechanical energy to get the electrical energy through
yes,
some
sir.
generator.
Yes, sir.
So the work which is available in the air, the kinetic energy which is available in the air, that is higher
Mm,
as compared to the shaft work which we are going to get.
yes, sir.
So work
Uh,
also we are going to lose. Work is not conserved,
yes, sir.
or you feel it is conserved.
So work is not conserved, but the energy is conserved because energy is
Work is also a form of energy.
yes. But, uh, but according to first law, we say that energy is conserved. I mean, total energy of the system is conserved.
Yes. To what word do you? One word you? Which particular word you need to use? Varun? Total energy is conserved.
Okay,
One form of energy is not conserved. Maybe heat, work, or any other form. But the
okay,
total
okay,
energy is conserved.
okay. Got it.
What do you understand by entropy, Varun? What is the significance of entropy in thermodynamics?
So entropy is the degree of randomness or the disorder. So
Tell
like
me more
if
about this entropy.
so, suppose we have given some energy to the system. The system will show that energy in the form of vibrations,
Mhm.
uh, and because of those vibration, energy will be lost, and this is due to the phenomena of entropy. So,
You
like
know,
degradation of
entropy.
energy is occurring.
Entropy
That
is a measure of unavailability.
yes, sir.
So can you convince me about that? How we can say that entropy is a measure of unavailability or unavailable energy?
So, like you told earlier, because of this entropy, some energy is lost. I mean, we cannot get the max total. Like we are giving some work to the system. Some work is getting lost, and that loss is because of this entropy. So we are getting some unavailable energy.
No, the loss of energy, the loss of work is not unavailable energy. Unavailable energy is the minimum energy which we need to
Yes.
reject.
Mm, so-
The loss of
okay.
work is known as increase in unavailable energy. whatever work we are going to lose, that is equal to increase in unavailable energy.
Okay.
What is your understanding related to second law of thermodynamics?
Second law has two statements. First is related to the heat engines, and second is related to the heat pump and refrigeration. According to the Kelvin Planck statement, it says that efficiency of a engine cannot be 100%. And the second statement of second law, that is the Clausius statement, it says the COP cannot be infinite. In other words, it says the heat energy cannot be transferred from the lower temperature reservoir to the higher temperature reservoir without any external work. So indirectly, it is saying that COP cannot be infinite. And the first law, the first statement of the second law states we cannot have the 100% efficiency. That is, if we're giving heat to the heat engine, it cannot convert all the heat into the work. That is, there must be some sink also. So that is the statement actually.
What is the difference between first law efficiency and second law efficiency?
So second law efficiency actually relates the actual efficiency and the maximum possible efficiency. That is the efficiency of a reversible cycle and that of reversible cycle. So we can define second law efficiency as the ratio of actual efficiency divided by efficiency of maximum possible efficiency divided by so 1 second, let me write that. Efficiency is actual by maximum possible. So second law of efficiency is defined as the ratio of actual efficiency divided by the maximum possible efficiency, and maximum possible efficiency is achieved in the case of reversible cycles only. So this is the statement of. And
what are the reasons behind irreversibility?
So friction can be a reason for the irreversibility. Also, the finite temperature difference is the reason for the irreversibility.
Finite temperature difference between what?
Between two systems. So
how can be there two systems? System will be one only.
The two bodies. If we have two bodies, they are having some temperature difference. Because of the temperature difference, heat will start to flow. But if there is a temperature difference, there will always be some irreversibility that will be associated with the heat transfer.
Okay.
Yes, sir.
What is zeroth law of thermodynamics?
So zeroth law give us the. It says if A is in thermal equilibrium with system C and B is in thermal equilibrium with system C, then A and B are also in thermal equilibrium with each other. So to explain this, we can take two glass of water. One is hot, one is cold, and if we place these two glass in the room, we can see that first glass of water will get in thermal equilibrium with the room. Also, the second glass will get in thermal equilibrium with the room, and after the thermal equilibrium of this glass and room is achieved, these two glasses will also be in thermal equilibrium with each other. It is used to find out the temperature.
Okay. What is a thermometric property? And can you tell me about the temperature measurement by a thermocouple? On what principle a thermocouple works?
Okay. So thermometric property used to find out, used to determine the temperature. Like to measure the temperature, we need some property, and that is thermometric property. And in the case of thermocouples, the EMF is the thermometric property.
What is available energy, Varun?
Available energy is the maximum possible work that can be obtained from the system.
Maximum work which we can obtain.
Maximum possible work when it goes to that state.
Fine. Acha, for example, my last question to you, if we will consider a fan as our system.
Yes, sir.
So some electricity we are giving and we are getting what the mechanical work, shaft work, and further we are utilizing that mechanical work in increasing the kinetic energy of the air. Okay.
Yes, sir.
So how you will calculate the irreversibility in the fan? Just give me some idea, brief idea about how you will calculate the loss of work in a fan or irreversibility in a fan.
Firstly, for the air, we will calculate the this entropy that is given by MC log nature T final by T initial. So that will give us the entropy of the air. And for the fan, it is electrical energy is getting converted into the mechanical energy. So, so for the I mean, electrical energy is high grade energy. So high grade energy do not have any irreversibility. So there the only
whatever
irreversibility.
electricity we are giving, that and completely will convert it to the mechanical work, shaft work.
No, there is always some loss.
Obviously, there will be losses due to the friction.
That is Q is given as I square RT. That will be the heat energy lost in the wires, and that will be absorbed by the atmosphere. So this Q by T will give us the irreversibility of the wires. I mean the total wire loss and the loss in the.
Okay, Varun. I think now I can provide you the feedback.
Okay,
so overall, your confidence, your technical understanding is looking fine. Some part actually you missed. I feel you are having some confusion between the unavailable energy reversibility concept. Okay. Remaining all your understanding is looking fine. I asked you some questions from first law and this zeroth law. All those you answered correctly. You know, energy conservation of energy means total energy is conserved. One form of energy is not conserved, whether it is heat or work. Total energy is conserved. Like in fan also, the total energy is conserved. Like whatever electricity we are giving, that is converting into what? The mechanical work plus some heat is going to be generated.
Yes, sir.
So whatever is the energy we are giving, electrical work, that is equal to what? The shaft work, mechanical work which you are getting plus heat lost.
Heat energy.
Are you getting?
Yes, sir.
So that is energy balance. That is conservation of energy. Total energy is conserved. One form of energy is not conserved. Now, if we will talk about irreversibility, irreversibility means loss of work. So, how much work we are giving? That is electric work. How much work we are getting? For example, that is a change in kinetic energy of the air. Kinetic energy is also a form of work. So, let's consider there is a stagnant air inside the room. So, how much is the mass flow rate of the air from the fan? How much is the change in velocity? Okay. So, from that, you can easily calculate the kinetic energy of the air coming out from a fan. Fine.
Okay.
So, the difference was the loss of work potential. Or let us consider the fan only as a system. So, if fan is a system, you can consider the mechanical work also, the shaft work which you are getting from the fan. That will be a kind of output. That also you can easily measure by a tachometer. You can measure the speed. You can measure the torque also. With that, you can easily measure how much BP you are getting, brake power. Are you getting, Varun? So the difference of the electric work minus the shaft work which you are getting, that is the irreversibility. W max minus W actual. Is it clear, Varun?
Yes, sir.
And obviously that is equal to what? That is equal to the heat lost. How you can say that? If you will use that equation, dQ equal to dE plus dW. dQ equal to dE plus dW. So dE is what? The change in energy of the system. You can assume fan is in steady state. Okay. And fan is not moving. It's change in potential energy, change in kinetic energy, change in internal energy is zero. You can assume fan is in steady state. So dQ equal to dW. Okay. There is no heat addition. So only there is a heat lost. So minus Q lost equal to what? Minus W electrical plus W mechanical.
Okay. Sir, can you repeat that again?
Minus Q lost. Okay. That is equal to minus W electrical plus W mechanical. Why W electrical will be negative? Because that is a work done on the system. Yes, sir. And W mechanical is a work output. So if you take minus common from both the sides, Q lost will come out W electrical minus W mechanical. Yes, sir. Is it clear? And that W electrical minus W mechanical is nothing but the irreversibility. Okay. Fine? Yes, sir. Okay. Fine, Varun?
Okay, sir. Thank you.
Okay, good luck. Thank you.